All right. So, what we discussed till yesterday was about what an algorithm is, what is its purpose, and how we compare different algorithms in order to find the efficient one among different algorithms. So, in the today's lecture, we will discuss about the important parameters which are used to find out the efficiency of the algorithms based upon two parameters. Yes, the space and time complexity. Okay, the amount of space or the storage space uh, algorithm needs for its computation, that is the space complexity, and the amount of time it needs for its completion to execute itself, that is known as the time complexity of that algorithm. The time complexity is denoted by T of n and the space is denoted by S of n, and n is the size of the input. So you see there are different functions by which we are able to find this space and time complexity. You know? There are some like big O of n, there is big O log n, O n square. These are all the different functions. When there is this O of n, it means the function is linear in time. Yes, whenever the value of a particular thing changes, the something is dependent on that thing. Okay, so whenever the value of this thing changes, this thing its value also changes, but linearly. Okay, if it's 2, it will be like 2. If it is 3, it will be like 3. But there is the quadratic function n square, big of n square. It means when the value of the first element changes, the value of the second element changes in terms of square. If it is 2, it will become 4. If it's 3, it will become 9. So you see, this is how the value of the functions increment or it increases. That depends upon the type of function which we use. So if there is an exponential function like big O 2 power n, so it means when the n is equal to 2, the value will be 2 power 2 4. When the value of the n is equal to 3, it will be like 2 power 3. 2 to the power 3, that is equal to 8. So based upon the different functions, we are able to represent the time and the space complexity of the algorithms. And this table gives you a look at how the value changes by changing the value of n. You see, there is this column number second, which stands for the linear. Okay, when the value is 1, 2, 4, 8, 16, and accordingly, if we calculate the value in terms of quadratic, that is column number 4, 1, 2, 3, 4. When the value is n square, it's not n is linear, n square is its square when we multiply it 2 times. So the value of 1 is 1, the value of 2 will be 4, the value of 4 square, that will be 16. Then there is this polynomial, that is n cube. When we put the value 1 to it, it will become 1. When we increase the value to 2, it will become 8. So the point is, when n is linear, that is 1, value is 1. When n is 2, in case of quadratic, it became 4. In case of cubic, it became 8. So as soon as we increase the value of n, the value gets increased to a very large number in case of quadratic and more in case of polynomial. And again, if you see the same value in exponential function, the last one, there is firstly when it is 1, the value is 2. When it is 2, the value is 4. When it is 4, the value is 16. Okay. And there are these other functions also, like the logarithmic function. The first one, log n to the base 2. When the value of n is equal to 1, the log function will give its value as 0. When it is 2, means log 2 to the base 2, the log function will give its value as 1. So you see the logarithmic function gives even lesser value than the value of n. If you put 1, n is equal to 1, the log function will return 0. If you put n is equal to 2, the log function will return 1. If you put n is equal to 4, the log function returns 2. So whenever you put the value of n something, log function returns something which is even lesser than the value of n. Okay. So this way we can say if the space complexity or time complexity of an algorithm is a logarithmic function, it means it will be very less, isn't that? But the reverse case is also true. If the space or time complexity of that algorithm is like exponential or like polynomial, you see polynomial is the cube. So whenever you put the value 3 here, n is equal to 3, the polynomial function will return your value n cube, that is 3 into 3 into 3. So it multiplies a number of times and it becomes very, very huge. So this is how the value of function changes, the value of the input parameter changes, which depends upon the particular function. So out of these 6 or 7 different types of functions, we reuse those functions to represent the space and time complexity of an algorithm. These functions we use. That's why here I gave a little information about. And on the right hand side, you see there are these functions are divided into different categories. One is the polynomial and the exponential. Polynomial you see are all the functions which are written on the top, and exponential in time are 2 to the power n and n factorial. These are the exponential ones. The other ones are the polynomial. When it is written in terms of n, like n is an infinity quantity, you don't know, it can go to anywhere from 0 to 1 to infinity. At that time, the functions are known as exponential. When it is written, when the power is in an integer type of, okay, or it's a logarithmic type of, at that very time, your function becomes the polynomial one, okay. So these functions are divided into 2 categories. So we will move forward. You see, if we are having, for example, two algorithms, like we discussed yesterday, 2 algorithms are there for the multiplication. And suppose algorithm A, it takes 5000 seconds, means a constant amount of time. It takes 5 minutes for you to walk from hostel to here. That's constant, isn't that? And this is for algorithm A. And algorithm B takes 100 into n. Okay, this is also constant, but you don't know the value of n. Okay, so depending upon the value of n, we can say whether algorithm A is better or algorithm B is better. So if we say the algorithm B is better, only if our problem size is less than 50, here in this case. If it goes beyond 50, then the algorithm first will be the better. Okay, so the value of n actually determines which out of the previous functions will be better for your algorithm. Which algorithm will be better, that will depend on the function it is represented by, and whenever it is represented by that function, then the value of n will determine, like we see it here. The type of function it will be represented by, and then the value of n. If n is a small value, accordingly it will produce this results. If n goes so much big, you see when n is equal to 2 to the power 10 to the power 3, linear case, column 2, yes, n is equal to 10 to the power 3 means 1000. You see exponential value, how much it produces, 10 to the power 2 raised to power 250, even much more that. And the logarithmic function produces only 9.96. So the complexities here are written in the order to demonstrate which function out of these are better and which are being treated as the worst functions. You just have a look on it If it's written in terms of constant value, these are the constant time. The time it takes for you to come from hostel to here, 10 seconds, 20 minutes, 20 minutes. Then when it is written in terms of n, means it's not constant, but it depends on n. And there is this logarithmic function associated with it. So it is a logarithmic time dependent. Then there is linear time. N varies linearly, not quadratically. N is equal to 1, 2, 3, 4. Log linear. There is n multiplied by log of n. This is also one function. N into log n. Quadratic when it is square, cubic, cube, and exponential when n is to the power of something. And if the complexity, I am talking about both complexity, whether it is space or time for the time being. If the complexity is of the algorithm is on the higher side, that is the constant, log, linear, no, the algorithm is that much of efficient. The performance of the algorithm will be that much of better. But if it's in the downward side, the functions which are complexities of that algorithm are towards the downside, like cubic or exponential, the less efficient or the more space and time it needs for that algorithm for its computation. Yes. So the goal is to find the efficient algorithms will be to have the algorithms which are having the efficiency or the complexity on the higher side of these functions. So how then we measure mathematically how we are able to find out the efficiency and the betterness of the algorithms from different. We call this as performance analysis. Performance analysis, two types, space complexity and computing time. The amount of time it needs for the program or the algorithm to get completely executed and the total space storage it needs, that is the space complexity. Okay, these are all these complexities are machine independent. These are not dependent on any machine. Okay, we are generally extracting those complexities of the algorithm as a general rule. Okay, suppose I am having a machine with a high configuration processor and storage system, and you are having a very old, for example, PC, maybe 5-6 years, which is having the core dual core processor, and now there are so much improvement in the processor. So if you execute an algorithm in that machine and this machine, the one with the highest speed, definitely that will run it very fast. Yes, but at that very time, that analysis becomes machine dependent. What type of configuration this machine is having upon which I am executing this. But when we talk about this analysis, that is the space and time complexity, these are all machine independent. No, whatever the machine is, they have to necessarily take that much of time. They have to necessarily take that much of storage. Okay, so we will generally analyze these algorithms. So the first complexity we will be dealing with will be the space. The amount of storage space a particular algorithm needs for its completion, that is known as the space complexity of that algorithm, denoted by S of P. And it depends on two things. One is the fixed part of the algorithm, the another one is the variable part. Okay, an algorithm could be having two parts. One is fixed, the another is variable. Fixed means that much of memory is always needed by the algorithm. Like if you are declaring the value int a is equal to 5, b is equal to 10. So if you go to any machine, if you go to any environment, you will always need the space for A and for B. It's fixed. Okay. And there is another component of the storage requirement, which is the variable size. Variable size is not constant. It depends upon the instantaneous characteristics. So if you are having a for loop inside a program, or a while loop, any loop, or a function, you are writing a for loop for I ranging from 1 to 10, for I from 1 to 10. So this is a for loop, and you don't know how many times this for loop will execute, whether it will execute 3 times, 4 times, or there is some break statement inside the for. Break means when the for loop does not terminate itself, but you are by force using an external command like break to terminate this for loop. The for loop condition is still valid, but you are still terminating it. So when this value ranges from I is equal to 1 to some parameter n, that part of the algorithm is called as variable length. Means you don't know at the very first step how many times this loop will execute. When you know that this much of memory is needed, a is equal to 10, b is equal to the constant variables, we say that it is the fixed length. And the variable space is when you initially don't know, when it is dependent on n, like that sort of. You can say the number of times a program will be called, a function will be called. Okay, it will get clear to you in the example given in the next slide. So in totality, the space complexity is sum of two types of storage requirements. One is the variable, and the other one is the constant, that is the fixed length. That is what is written here. SP is equal to C plus S of I. C is a constant which is known to us, that these are the constant values, these are integers, these are floating point. Integer takes 2 bytes of, floating point takes 4 bytes of, this thing, this is known to us. And the number of times, when it depends on the particular instance कि कितनी बार repeat हो जाएगा एक loop, अभी हमें नहीं पता है. Instant time पे जब depend करता है, किसी भी time पे, we don't know initially. So that very time, it is the variable space which is written as SP. And space, जब हम space complexity की बात करते हैं, so this is the second one, that is S of P, जिसकी हम बात करते हैं, which we are dealing with. We don't deal with the constant part because no doubt whatever the machine you are hang, the constant part will always take that much of time. Yes. So what we are focused upon is the variable part. And इसी चीज को find out करने के लिए हम space complexity की बात करते हैं. See, we are hang an algorithm 3. Yes, it is a simple algorithm function जिसका काम है कि ये हमें एक अरिथमेटिक ऑपरेशन को कंप्यूट करके देता है. अरिथमेटिक ऑपरेशन क्या है? It's a plus b into c, something like that, plus 4 point something. So we are having these variables, and whenever we compute the arithmetic operation of those variables, we add 4 to the result and return that value to the algorithm ABC. Yes. So if you implement this algorithm, it means what? A, B, C, these are all the variables, whether these are integer or floating, but these are all the variables. If these are integers, it means every one of them we require 2 bytes of, and if it is we declare is a floating, it means every one of those variables will require 4 bytes of storage. Okay, so without caring about to which machine you will operate this software or this program or this algorithm, whatever the machine you will use for algorithm 3, you see you already know the total amount of storage it will need. For A, it will need 2, for B, it will need 2, for C, it will need 2, for floating point, it will need 4.00, the last one. Yes. So since the constant part is here, everything is here constant, you already know. But as we discussed in the previous slide, when we are computing the space complexity, we deal only with the variable part. Variable part is what? S of P. So S of P means S of P stands here for the algorithm. Algorithm is ABC. The name of this algorithm. It will be equal to 0. because here nothing depends on the particular time. Everything is already known in this algorithm. Now coming to the second algorithm, you see it is an algorithm which computes the addition of the numbers from 1 to n. A simple iterative algorithm. Initially, we declare a variable, a floating point s equal to 0, and we initialize it by 0. उसके बाद we start with a loop from 1 to n, जो इस array का size होगा 1 से लेके n तक. और हम क्या करते हैं, in every step we do कि जो s है, s में वैल्यू को आप अपडेट करते जाइए. जो पुराना वैल्यू है s में, दैट इज 0, उसको ऐड करते जाइए जो एरे का पहला एलिमेंट, a ऑफ 0, a ऑफ 1, a ऑफ 2, a ऑफ 3, ऐसे कर करके जो एरे में अगर 10 एलिमेंट है एरे में टोटल, फ्रॉम 1 to 10, a1 plus a2 plus a3 plus a5 that all will be stored in s. उसके बाद we return s and the return statement s gives us the total sum of this array. Now you see again here we know the s is initially an floating point, so it will need 4 bytes, okay? But then there comes the for loop, and we don't know for how many times this for loop will get executed, okay? Because n, it is depend on a variable, that's n. So we don't know initially, so it depends upon instantaneous characteristics. It's not constant, it is variable. If the loop will execute only 10 times from 1 to 10, so it will need space for 10 variables, yes, because the array will be of size 10. If the loop executes for 20 times, 1 to 20, it means the array size is 20. So we need the integer space for how many? 20 variables, yes. So it all depends upon the programmer. We initially don't know the total space it will require, and since we are focused upon the variable size, so we will find the variable size of this algorithm. It will be sum, s of sum means the algorithm, and its I, it stands for the variable space requirement, that will be greater than or equal to n plus 3. How? N is simply the number of times the loop will be executed. The number of times the loop will be executed will determine the total number of elements in the array, that's n. So we don't know whether it's 10, 20, 50, whatever it is, so we will keep it as n plus. Then there are 3 variables which are declared in this algorithm. One is n, yes, it has to be declared from 1 to 20, yes. Then there is I, that is the index variable कि कहाँ से start करना है, and then there is s जिसमें आप sum के result को store करते हो. So these are 3 variables which are declared in this algorithm. So the total space which this algorithm will need, I am talking about the variable space, because in space complexity our goal is variable space. That should be always greater than or equal to n plus 3, but not less than that. अगर इससे कम होगा तो आप देख लीजिए our storage requirements will be less. हम इसको store नहीं कर पाएंगे किसी भी हाल में. अगर n plus 2 ही होगा, since we are having 3 variables, है ना, n तो for loop के लिए है, अगर 2 ही होगा but we are having 3 variables, where will we keep the third variable? So this is the least amount of storage which will be needed by this algorithm when it computes the sum from 1 to n. It could be even more than that, but this is the least, not lesser than that. समझ आ गई? अब ऐसी और एक एल्गोरिथम है, दिस इज द रिकर्सिव एल्गोरिथम ऑफ एल्गोरिथम 4. एल्गोरिथम 4 जो काम करता है, the same work is being done by algorithm 5, but here instead of using a for loop we use a recursive loop to call the function continuously inside its body. That is called a recursion. So again we write down the algorithm and its name or sum, giving the parameters a comma n. So what we say, there is this if statement initially. We say if n less than or equal to 0, देन रिटर्न 0। अगर n की जो वैल्यू है दैट इज या तो 0 है या 0 से लेस है, ओके, मीनस माइनस, देन रिटर्न 0, देयर इज नो सम बिकॉज देयर इज नो वैल्यू, देयर इज नो एलिमेंट। एंड अगर ये चीज नहीं है तो आप फिर से आर सम को कॉल कीजिएगा a comma n minus 1 plus a of n. The recursion will be called each and every time by decrementing it with 1 1 1 1 1। अब फैक्टोरियल पढ़ा है ना, फैक्टोरियल, इसको रिकर्शन को आगे हमने पढ़ना है इन डिटेल। So you see here in this case, since it is also dependent on n, the number of times the recursive function will be called. So it is the variable part. You don't know initially how many times the recursive function will be called for its execution. Yes. So when we talk about the variable size, so in order to find its variable size, as sum of I will be greater than or equal to 3 into n plus 1. 3 is for, you see the last statement, whenever the total number of calls which we have to make to this recursive function, that will depend on n plus 1 is the depth of this recursion. Depth means n is the number of times it will be called the recursive function r of sum, that is dependent on n, and n plus जो ये 1 है that will come from if n is equal less than or equal to 0, the first statement. So इतनी बार तो ये कॉल हो ही जाएगा, n is for r sum, and जो if कंडीशन के लिए है that will be checked once, एक बार वो चेक होगा, and the number of times will be called the recursive function. So n plus 1. Now 3 क्या आएगा, 3 is for what, जब n plus 1 बार इसको कॉल किया जाएगा इस रिकर्सिव फंक्शन को, n is for what, n is given here for values of n जो हमने ऊपर डिक्लेयर किया एल्गोरिथम आर सम a comma n. n is itself a variable, yes, the return address and a pointer to a. There are 3 variables which we need here in this algorithm. One is for the n, another is for the a of the pointer to a of array, और the third one will be the return address, क्योंकि हम बार बार जब रिकर्सिव फंक्शन को कॉल करते हैं तो उसका हमें एड्रेस सेव करना होता है स्टैक में. So 3 variables we will need, and number of times this function will be called n plus 1. So हर एक बार में हमें 3 वेरिएबल, एक बार में 3, 2 बार में 3, 3 बार में 3, 4 बार में 3, तो ऐसे ही n plus 1 बार में 3 into n plus 1. This will be the storage which we need, the total variable size which we need while calling this recursive program, greater than or equal to 3 into n plus 1. Now coming to the time complexity part. Time complexity is what, the total time an algorithm needs to its computation to its execution. Again, a program is divided into 2 steps. Firstly, we compile it, then we run it. Yes. So it needs some time to compile, which is known as compilation time. Once we compile it, then it needs some time to run, to execute, which is known as runtime. And when we talk about the time complexity of any algorithm, we talk about its runtime. Like in the space case, we said when we talk about the space complexity, we talk about only its instantaneous space requirement, which we call as variable length storage, not the constant one. Yes. So here also we talk about a runtime, not the compile time. So whenever we calculate the time complexity of any algorithm, anybody, if somebody asks you, you have to keep it in mind that it is the runtime which we are talking about, not the compile time. Okay. So the total time complexity is equal to C plus T of V. C is again constant, which is compile time, which we are not dealing with. And T of P is the execution time. And this is what we will be finding for the algorithm when we deal with the time complexity. Yes. So suppose we are writing an algorithm and it contains some arithmetic operations like addition, subtraction, load, store. These are the actual functions which an algorithm does. कोई काम ही तो करता है ना, अर्थमेटिक ऑपरेशन ही करता है. तो अगर हमें पहले ही पता हो कि इस एल्गोरिथम में there are those functions like addition, some functions of subtraction, some functions of load, yes, and then how we will find its instantaneous time characteristics. What we will do, we will see the total number of additions inside it, the total number of subtractions inside it, and the total number of multiplications. There are all the arithmetic operations inside that program, and we will multiply each arithmetic operation by the time it takes. If it takes 10 seconds for addition, we will take 10 and the number of additions which it does. 10 into अगर addition 5 होगा, 10 into 5 plus we will add it with what? The total number of subtraction instructions and the time it takes for one subtraction. You see, there is this formula TP of n. This is the ideal situation. If we already know the total number of additions, subtractions, multiplication inside a particular algorithm, and the amount of time it takes to compute one addition or one subtraction or one multiplication, है ना? तो एक बंदा, it takes one person to do one task, addition, it takes 5 minutes, and if we have 5 addition instruction, it means 5 into 5. That is what is CA into add of n. CA means the number of addition instruction. Add of n means that it takes how much time it takes for one instruction. So for complete the whole addition instructions, it will take CA into add plus there will be other arithmetic operation like the same way, subtraction n into number of subtractions plus load of n, all those arithmetic operations. But what is, if we calculate this time, it will give the total time this algorithm will need. But what is the problem with it? The problem is simply that we are assuming we know initially, we know at the starting the total number of additions in the program. Even if we know that, we don't know how much time it will take for one addition operation to get completed, for one subtraction to get completed, because that depends on a lot of things. That depends on the numbers you are adding. If you are adding a very large number and if you are adding a very small number, the addition will take place less time, in which case the small number. If you are adding a complex number, it will take more time than a simple number. Likewise, if we even know the total number of additions and subtractions, this formula still won't be valid to find the time complexity of an algorithm, because of this reason. The reason is what? We don't know how much time it will take for one arithmetic operation. Even if we know, still it depends on the type of data or the type of operands upon which we are performing the operation, कि किन चीजों पे हम ये काम कर रहे हैं. एडिशन किस पे हो रहा है, मल्टीप्लिकेशन किस पे हो रहा है. अगर बड़ा नंबर है बनेगा, उसकी कॉम्प्लेक्सिटी अलग निकलेगी, बिकॉज दिस वोंट बी ए जनरल फॉर्मूला. सो इस चीज को ओवरकम करने के लिए we are using a concept that is known as program step. A program step is also a set of instructions inside an algorithm. ये algorithm से बाहर कोई चीज नहीं है. This is itself inside the algorithm, and we count the total number of these program steps inside the algorithm. We count it. और जितना काउंट इसका आएगा, we say it will take this much of time. Okay, the program count is itself a syntactically correct statement inside the algorithm, and we count the total number of the program steps. The total number जो इसका होगा, that will give the total time complexity of that algorithm. Sure. So जैसे in the previous slide when we talk, we gave the examples of these algorithms when we computed the space complexity, and we will use the same algorithms as example in case of time complexity, and that is the example which is given here. A plus b into c, it is the same algorithm which is given in the previous slide, whose space complexity we find. Now at this very time we will find its time complexity. So there are two broad methods. When we find the time complexity, we find the program steps, and program steps को find करने के लिए two techniques है या two तरीके हैं. One is the count method, the another one is the table method. Okay, so अभी हम count method की बात कर रहे हैं. Count, the first one is the count. So count क्या होता है? Count हम एक variable को ऐड करते हैं प्रोग्राम में. अभी तक हमारे एल्गोरिथम में यहाँ पे देख लीजिए, any algorithm, you will see there is no count, count. But now when we write down the new algorithms of the same algorithm, previous ones, we will incorporate one more variable, that is count. Here you see count plus 1, count plus 1. Okay, so since we use this variable to find out the total number of program steps, that is why this method is known as count method. Simple. So जो comments होते हैं, the comments inside an algorithm, those are given zero program steps, because we said program step जो होता है, that is a logical, semantically and syntaxically correct computing part of an algorithm. Since comments are ignored by any compiler, these are just for the programmer perspection, so these are given zero program steps. Comments are not given any program step, no count. Yes, and if it is a any assignment statement, colon and equal assignment state, any assignment statement which is there in algorithm, that is given one step, one program step. Commit is 0, assignment statement 1, and any looping statement, whether it is for, while, whatever, do while, the total number of program steps it is being given, it is a rule, it depends upon the value of n, the number of times that loop executes or that while statement executes. So we will see, this is an example of the sum. This program algorithm 4, यहाँ पे हमारा काम क्या था? We were having an algorithm sum, we were giving it the array and the total size of that array and telling it to help us in finding the total sum of that array from 1 to n. And the same algorithm is written here, but after incorporating the count variable in its pseudocode. So again, what we do, we see the algorithm sum a comma n. This is okay. Then there is s, that is the sum variable, that is initialized to 0. And as we said, once there is initialization, we give one program step to it. One program step means we give one count to it, count plus 1. That is why just after the s finishes there is count plus 1, isn't it? And it is written count is global, it is initially 0, क्योंकि यहाँ पे initialization हो गई. That is why as per rule from the previous slide we have to use one count here. Then comes the for loop, that is itself in the algorithm. So here we did not make any change, but once we go inside the statements of the for loop, once we go inside its module, we have to use another count function. This is for n, कि for loop कितनी बार चलेगी, इसीलिए हम इसके अंदर इस count को हमने declare किया. That is inside the loop. This is for the for loop, the number of times the loop will be executed for. Then we do computation. S is equal to s plus a of i. Sum for summing, कि s में जो पुराना वैल्यू है s का उसको ऐड करते जाइए किसके साथ, जो एरे का पहला एलिमेंट है a of 1, a of 2, a of 3, a of 4, a of 5, ऐसे कर करके जितने भी टोटल नंबर ऑफ एलिमेंट्स एरे में है उन सब का सम करके s में आप डाल दीजिए. So this is for what? This is for summation, total sum. And total sum ही पर्पस है इस एल्गोरिथम का, कि एक एरे का टोटल सम करके दीजिए from 1 to n. और again here, since it is an assignment operator, s is equal to s plus a of i. So this is assignment, and assignment के लिए भी हमें count क्या करना, वो count plus 1. ठीक है. अब ये assignment operator कितनी बार चलेगा उतनी बार count को भी multiply हो जाएगा. Count हम assignment के लिए 1 देते हैं, but the number of times this assignment will be executed. If I is equal to 10, I, a of I, so it will execute from 1 to 10. So assignment operator भी 10 बार execute होगा, तो count को भी multiply हो जाए 10 के साथ, है ना. एक assignment के लिए count 1 बार होता है. उसके बाद जब हम बाहर निकलते हैं for loop से, क्योंकि अगर for loop हम ऊपर जो लिखते हैं for I is equal to 1 to n, अगर हम फर्ज करें n is equal to 15, मतलब कि I फॉर लूप को चलना है 1 से लेके 15 तक, और जब 15 होगा उसके बाद फिर से I एक बार इंक्रीमेंट होगा, I प्लस प्लस दैट विल बिकम 16. और तब ये फॉर लूप का जो लॉजिक है जब हम इसको इंप्लीमेंट करते हैं हम क्या बोलते हैं, फॉर I इज इक्वल टू दिस थिंग, I लेस देन और इक्वल टू समथिंग. तो जब ये 16 बनेगा हम वहां पे हमने लिखा होगा I लेस देन और इक्वल टू 15. अब ये लेस देन और इक्वल टू 15 नहीं है, ये इससे ज्यादा होगा, एक 16 हो गया, तो फॉर लूप खत्म हो जाएगी, तब कंट्रोल चला जाएगा फॉर लूप से बाहर. बट जो ये वाला काउंट है जो हमने फॉर लूप के बाहर निकाला, ये फॉर लास्ट टाइम फॉर, ये उसी चीज के लिए है जब फॉर एक बार ऐड होता है 16 बन जाता है, ये वाला काउंट उसके लिए है. और द लास्ट काउंट इज फॉर रिटर्न स्टेटमेंट, फॉर रिटर्न आल्सो वन काउंट इज देयर. यस. So for this type of program, how many total count statements will be there? If we count the total number, because our program step is the number of total counts inside the program. See, the initialization, the first one on the top, s is equal to 0, count is equal to count plus 1. It will be executed only once because there is no n. So it will be count plus 1. Once we go inside the for loop, yes, count is equal to count plus 1. It will be executed n times because it depends on the value of n. For loop कितनी बार चलेगी, so ये वाला n टाइम चलेगा. जब नीचे आएंगे s is equal to s plus a of I. a of I again depends on the value of n. उतनी बार चलेगी I की भी value, so again it depends on n. Means this count plus 1 will be also n times. So वो वाला n times, ये वाला n times, दो बार n times means 2n. 2n प्लस ऊपर वाला काउंट होगा एक बार, नीचे वाला काउंट होगा एक बार जब फॉर 16 बन जाएगा और ये लेस देन इक्वल 15 हो गया 2 बार, और रिटर्न के लिए 3 बार हो गया 2n plus 3. That will be the total number of counts inside this program, and that will be the total number of program steps inside this program, and that will be the time complexity of this program. And here it is given the total number of program steps inside this program will be 2n plus 3. इसको हम फिर से नेक्स्ट लेक्चर में करते हैं स्टार्ट यहाँ से, ठीक है. आज के लिए थोड़ा ज्यादा होगा ये मुझे लगता है। हाँ सही समझ आ गया। हाँ मैं ये टॉपिक जब खत्म होगा ना उसके बाद मैं शेयर करूंगा सारी, है ना।